Hi, this is David or Dave, and welcome to my YouTube channel. In this video presentation I will be talking about an interesting mod or modification that I have done on my external USB battery cradle dock charger for my Samsung Galaxy Note 4 battery. Now the mod that I did was on this particular device that you see in front of you. Of course, this is only the packaging. I will show you all sides, but the device itself after I take it out of the box. But first I'm going to explain a little bit why I ordered this off eBay. Naturally, of course, the link to this is in the description part of the video, so you can get yours as well and then follow in my example to make your own mod with the purpose of testing the capacity of your battery in your Samsung Galaxy Note 4 smartphone. I ordered this cradle dock in I think it was mid-August previous year, so 2017, and it arrived in about 14 days. But the reason why I decided to purchase this was the following. I was having interesting problems with overall endurance, durability of the battery in my Samsung Galaxy Note 4 smartphone. And the problems started appearing something as early as I think February last year. And the problem that was happening was that, for instance, when I would have the phone charged up to 50% of battery capacity, it would just automatically shut down, sometimes even at 70% and similar. At that time, I just simply brushed off the reoccurring symptom to a possible overheat of the phone, regardless whether it was the main processor or the GPU. I thought this was probably the main reason as such, so I disabled all of the background services or apps that were running in the background in order to maximize or preserve the battery capacity that was reserved for other much more vital functions or services that run in the background of my smartphone. However, even despite of this fix, the problem kept on reappearing, repeating, sometimes even more frequently than other times. So I did even further digging on the internet, and I came to an additional possible two scenarios that might come into play. And one was naturally the most obvious one, a failing, diminishing capacity of the removable battery in my smartphone. While the other one, which I was much more afraid of, was that I had a fault on my charging circuit that is also in my phone. Because, at least to my knowledge, there isn't any efficient way through an app that you can measure the capacity of your battery in your smartphone. And I didn't want to disassemble my smartphone as well. I said, well, let's try it first by determining what is the actual capacity of the original battery that came with my phone. So I decided to order one of these cradle docks because I was hoping I could modify it in some manner so I could attach one of those USB power monitors or power testers, so I could somehow test the battery for its actual capacity, or at least the usable one. I was actually very successful in adapting or modifying this battery cradle dock in order to suit my need for my experiment that I wanted to determine the actual capacity of my original battery of my smartphone. So now I will, of course, first show you a little bit about the outside packaging in which this cradle dock came, and then I'll open it up and I'll show you the mod, and we'll continue from there on. So this is how it looks like from this angle, and then here you have the information. There's nothing over here. Let's turn to the back. Oh, it's basically the mirror image without the battery. Okay, so now we will take it out from the box. Oh, of course, here you have the label that this is for the Note 4. so it is very compatible with what I want. So this is how it looks like when you take it out of the box. It comes in a Ziploc bag, and this is the actual unit. So let's have a closer look. Here you have an opening, or this is the LED indicator. I think this is a RGB type of LED, so red, green, blue. I mean, it simply changes color accordingly to the program on the board. And here in the back you have the micro USB female port or slot. Here you would attach your USB cable, and then the other one would go to something like your power bank or a AC USB wall charger or adapter, so you can even charge the battery from your Note 4 externally in this manner. So power bank or AC power adapter option. And so when you put in the battery, here you have two gold plated pins at the bottom, so you cannot actually miss. Then the red LED would light up, and then when the battery would be charging, it would change. It would go from red to yellow, and then when it would be fully charged, to green. So very easy. Okay. Now this piece of plastic here, which is actually sticking out, this was originally quite firmly pushed towards the rest of the enclosure, but I was able to actually remove it, so it wasn't glued into the overall enclosure or the body of the cradle dock, but it is removable. I had to have a little battle with it to try to push it out, but in the end I managed to succeed in this. So when you take it out, ta-da! So I have inserted a standard USB 2.0 female connector inside this. So I was actually very much surprised when I managed to remove that strangely shaped piece of plastic out of the overall plastic enclosure of the cradle dock, because, you know, if this was only intended for charging externally the Note 4 battery, why couldn't they just simply, you know, fill the plastic here so it could be completely filled out? Why did they leave it in such a manner? Why the opening? You know, but nevertheless, because even this piece of plastic is very weirdly shaped or done, because it isn't a single piece, it's detachable. You know, very strange design indeed. So you can just put it on here, and it can also just, you know, slide all the way. So very strange. This cradle dock is very easy to be opened. I think originally here was a sticker, but I removed it. So here you have one Phillips screw, so we're going to unscrew this. So then I'm going to show you how I made the connection from the USB connector to the circuitry that is here inside. This side over here on the bottom side of the enclosure, I think this is some sort of a rubber. So when you place the dock on a, you know, hard flat surface, so it doesn't move around, so it provides some sort of friction or traction with the surface, so it doesn't fall off your table or something. So when you unscrew the Phillips screw, this is basically a two-part enclosure. It just simply pops out. So let's look at the bottom of the enclosure. So nothing in particular here, nothing special. So now we're going to look on how I made the wiring or the connection. Now this is much more up close on how I made all the necessary connections. What I've basically done is a very rudimentary, simple electronic bypass, to be precise. Here, of course, you have the PCB data code or version of the schematics. Sadly, I actually cannot extract the PCB from the rest of the top side plastic enclosure, because then I would have to tear down the already established connections. So I would have to desolder this part here, here, and of course on the USB 2.0 connector as well. But in essence, on the other side, you have a charging system, something similar of a TP4056 circuitry that you can also order as a separate PCB on eBay, by the way. Another thing underneath right here, I was actually wrong. I stated a couple of moments ago that this Cradle dock probably has a single RGB LED. It really has two separate SMD LEDs. So one is green and the other is red. I don't know which one is which, but that is how is the actual status of this circuitry. So I was wrong. Now if I was to briefly or a little bit more in detail describe what I've done. So when you insert your Note 4 battery into the Cradle dock, basically underneath or towards the end of the enclosure on the PCB you have two gold-plated spring-operated pins that are then of course naturally soldered on the PCB. And then when you insert the battery into the Cradle dock, they of course retract, but nevertheless they still establish connector with the gold-plated surfaces on the battery. So here you have the plus terminal or the plus polarity and the adjacent minus terminal. Now then the plus terminal, the electronic bypass goes through this solid strand nickel-plated copper wire on this part of the terminal of the USB 2.0 connector, and the same for the minus terminal or the minus polarity of the battery. It goes on the far left side of the connector. As you can see here, but also underneath you have a little bit of exposed circuitry, so I had to add a little bit of insulation on this solid copper wire that leads from one side of the circuitry to the far right connector on the USB 2.0 jack for safety reasons naturally, so I don't want to cause a short and destroy the whole circuitry and perhaps even the battery, so always have safety in mind. Even though these two solid copper wires are actually much more lifted off the board, I'll show you that. So as you can see, they're not running exactly on the surface of the circuitry. I decided to lift them a little bit, but I couldn't lift them a lot because then they would be pushing towards the bottom side of the plastic enclosure. So now when you would connect your USB cable to the micro female side of the connector on the board, and you would of course naturally prior to that already or afterwards insert your Note 4 battery into the Cradle dock, the battery would normally charge, and when it would reach full charge and the green SMD LED would light up, you would then disconnect the cable and then into the USB 2.0 port or connector in here on the other side. Then you would attach your USB power monitor or power tester with the appropriate load tester as well inside. Now, this example of a USB power meter or power detector monitor would be a very good example of what you could use in your experiment in order to determine what is the actual usable remaining capacity of your original or replaced Note 4 battery. After, of course, you would hook up this meter into the USB female connector on the Cradle dock, and then afterwards, of course, you cannot do anything without a suitable load tester as well. You would plug in this USB load tester into the port of the USB power meter, and then you could start your experiment. Even though in my case I used one of my custom USB load testers. You've seen this one in my video when I was testing the 12 volt VRLA or seal lead acid rechargeable AGM type of battery, alongside with 2 other custom USB load testers that I made using my rudimentary soldering skills. Still very handy. Now another final note on this circuitry or the electronic bypass that I made. These copper wires that are, I think, nickel plated, I have clipped these off much larger resistors because I wasn't really sure how much is the amperage consumption when you test the Note 4 battery. So it's always best that you use thicker wires than not thick enough or slimmer ones. But in my experiment, when I was testing the actual capacity of my original Note 4 battery, the current consumption was, well, you could say it was high, but it was actually very low, somewhere between 300 and 400 milliamps. More than enough for these wires to take that load as such. As noted a couple of moments ago, so when you would want to test the capacity, the real one of your Note 4 battery, you would just simply put your battery from your Note 4 smartphone in the Cradle dock. You would of course attach your USB cable to it, and that to a power source, power bank, or a AC wall adapter. And then when the battery would be fully charged, the green SMD LED would light up on this part of the enclosure. Then you would disconnect the cable, and then you would insert your USB power monitor or power tester and attach a suitable load to it, and then you would start the experiment. Now, what is the lowest possible and safe discharge voltage that you can discharge your Note 4 battery? Well, here probably there'll be much debate, but when I was running the experiment or the test for my original Note 4 battery, I discharged it to, I think, 3.2 volts. Maybe I could have gone to 3 volts. Maybe I did. I can't really remember. That was, quite some time ago. But nevertheless, the end result was that the battery had 250 milliamp hours of remaining usable capacity. That, in comparison to the original nominal capacity when the battery came from the factory or with the phone as such, was, I think, 3,220 milliamp hours. So that's quite a drop. So of course I threw or discarded the battery. Sadly, I don't have a spare Note 4 battery laying around, so I could give you a much more interactive demonstration on how my mod or adaptation works, how you can test externally what is the actual usable capacity of your Note 4 battery. However, nevertheless, I will be linking or adding all the necessary links on where you can get the USB load tester and the allotted power meter on eBay, so have no fear in that regard. Everything will be in the description part of the video. So in conclusion, in order for you to carry out or execute this mod or adaptation, you definitely need to have some soldering skills and of course naturally a soldering iron, because this isn't such a mod that you can do just simply by twisting the wires. You need to have some soldering skills for this. Maybe I should have mentioned this at the start of the video presentation, but well, better late than never. In the end, however, even though if you do perhaps know of an Android app that can precisely test the actual capacity in your smartphone, please do let me know in the comments section. I would be really glad of that information. I hope that you enjoyed the video presentation, that you learned something new, you found another interesting project that you could dive into. So for that matter, leave the like button checked, share, subscribe, and if you have any other questions, if you found anything to be unclear, if you have some suggestions, additional ideas, leave all that in the comment part of the video. and I'll see you in another video very, very soon. So this is David. Goodbye.